Hmm. Okay. Hello, everyone. So, in this segment, we will be talking about concreting. So, firstly, let's understand what a concrete is. I'm sure concrete is a very basic thing any civil engineer should know. So, definitely, it is a mixture of many materials. That's why it's a heterogeneous mixture of coarse aggregate, fine aggregate, cement, and water. In some special cases where admixtures are used for the proportion of the water cement ratio mix. So this is concrete. So the placing of all of this particular concrete in the buildings that has to be constructed is where it is called as concreting. And coming to concreting, like I've been telling from scratch, we'll be telling all of the details with respect to the processes that will be happening at any construction site. So there are five different stages when it comes to concreting. This concreting involves the process of batching firstly. So the process of measuring different concrete materials. What I mean by concrete materials is the same thing. The cement, aggregates, sand, water, all of these things mixing together will be coming up as the concrete. So this particular batching of all of these individual items is called as the batching, and this batching will be made in two different types. One is the volume batching and one more is the weight matching. Sorry, and one more is the weight batching. So in volume batching, all of these measurements of these particular concrete are actually taken by volume. On the other hand, we have all of the measurements of these particular materials that is taken via weight. Next, coming to, we have mixing. So in this particular process, all of the materials that has been batched, that has been calculated as per the amount of ratios based on the grade of the concrete that has been required. Based on that, the mixture of all of these materials is made sure. So the mixing of all of these materials should be made thoroughly, because it should be there in right proportions until this particular paste shows a uniform color and there is a proper consistency where the workability of the concrete that you will be using for the placement of this concrete that will be happening. That's why mixing of all of these aggregates in a very right proportion, in a very workable format, in proper consistency is where it definitely matters a lot. So now, starting, you have a lot of the concrete materials that has been batched. Now all of them are mixed with proper consistency. Now what? You will have to be transporting it to the site where you will be executing it. Sometimes what happens in the site only, the particular mixing of this concrete happens. Sometimes you will be making use of the RMCs, that is the ready mix concrete. So just in case there is a batching plant at one end of the city and the actual project is there at the other end of the city. So that time RMCs or various other alternatives will actually have transport will be transporting the required concrete that is necessary for the construction purposes. So now when it comes to transportation, after all of these materials that has been transported at the site where it has been executed, so correctly all of these things should be placed on the formworks. So the formworks that is provided, that is the supports that has been provided before casting of these particular concrete, will take in the picture. So this transportation also, it happens in two ways. The one, it is the manual way. So manually, it's like in one end of the corner of the site, you will have all of the materials that is stacked, which is pretty much close by to the storage of the particular site. So, and right next to it, you will be having the QA QC department. So there, the testing and the mixing, all of those things will be happening in one section of the site. So now there will be concreting that has to happen completely on the other end of the site. Say, for example, this is for a villa project. So villa project, definitely it will have a whole layout by itself. So where in this whole layout, if the batching plant and all of these things is put in one corner, now the concreting has to be transferred at the other end of the layout. So that is where this manual, or just in case, depending on the distance, obviously, manual transportation can be made with the hand trolleys, or when it comes to, like I mentioned the other time, if it is there in one end of the city to another end, then RMCs. Or apart from that, if there are conveyor belts that has been put across, then mechanical transportation also can be put into the picture. That also comes into the picture. Next, coming to compaction. So compaction, obviously, this is mainly used in elimination of the air voids that has been there. So once the concrete mix has been made, we have to make sure none of the air voids, none of the air bubbles or any void spaces should be there within the concrete, because that definitely decreases the whole durability, the whole strength of the concrete. The whole purpose of why concrete has been made, it will be slightly reduced. The characteristics of concrete will be lost. So for that reason, we will have to make sure that the compacting is made thoroughly. There are multiple vibrators that has been used for compacting of all of these concrete. So we'll have to make sure all of the uh, concrete that has been placed is equally compacted in order to eliminate all of the air voids and the air bubbles. And then finally, we have curing. So curing is a process where you will be like, uh, like the concrete that has actually been stacked, that has already been placed, you will have to keep that particular surface structure in a moist state. This purely to gain the strength. The concrete will be gaining strength based on the days that has been passed after the concrete has been casted. So based on that, the amount of strength will be calculated for it. So one, to keep it moist, and there is a lot of hydration process that will be taking place. So these are the very basic essence that is there with respect to curing. So the whole process takes place in this 5 major stages. So this is more or less like a brush up that had happened from the 4 years of your engineering, I believe. So batching, mixing, transportation, compacting, and curing are the 5 major process that a concreting will definitely go through. So now completely, let's have a look at how exactly one of these process or one of these steps are interlinked with another one. So here is a complete flow of the concreting process. So firstly, you can see that there is cement. So cement is completely bashed one side, aggregates are completely bashed on the other side based on the shape and the size of it, whether it is elongated or flaky stones that has been there. You know what are the kinds of aggregates that is to be eliminated. Then comes to chemical admixtures, just in case if it is a special purpose. So if it is a desert region, for example, so what kind of what is that, retarders that you will be using there, what kind of mixtures you will be using there, these things will be coming into the picture. And then coming to this supplementary cementing materials, just in case what is that, the composition quantity of the cement that has been there, for it to bind across with what exactly is the alternative supplementary materials that will be used. That is another kind of materials that can be used for the concreting process. And then finally, the water, definitely for the water cement ratio that is actually required for the workability of the concrete, for for any kind of casting of the concrete that is to be there. So all of these things play a vital role individually, without even having an interlink within each other. So these aggregates, as you can see an arrow mark between the aggregate and the water there. So that is purely for the washing purpose. So all of these aggregates, definitely there will be a lot of dirt or unwanted waste items that will be accumulated with respect to the surface boundaries of the aggregates. So in order to wash away all of these things, it has been linked with the water. All of these that is batched individually, all of these concrete materials that is batched individually will all combine together in the form of the mixing stage. That's where the mixing stage is mentioned. definitely it shows what is the performance of the freshly prepared, the new concrete that has been there. So this, I'm sure it'll be like some ingredients that is there, and you're trying to mix something and you're going to cook. So it's like very similar to that. There are multiple materials that is there. You're mixing up, but you're going to build something over here. So once the performances of the freshly prepared concrete has been tested, then we will be moving forward with how exactly to move it from one place to another. So where the concrete will be prepared is at a separate state, at a separate place, and where exactly it will be casted, it will be on the separate place. So that is where transportation comes to the picture next. And finally, transportation and placing of the concrete once it has been made, how this hardening will be happening. So again, the water will be linked again to this hardening, because curing definitely involves the gunny bag curing, or it might be water spraying. There are multiple sources where you can try to cure the concrete that has been casted. So this definitely gives the performance of what is the strength that has been gained by the concrete for the next durability of that whole structure will be gained at this particular stage. So this is where we will be involving with the complete flow of the concrete. So once all of these concrete has been placed, there is one thing we'll have to definitely remember before we go and cast this particular concrete. This is the whole process. Definitely there should be some amount of testing that is to be made. So the whole of this concrete will undergo through multiple tests, and I'm very sure that everybody will be definitely aware of all of these. It's just like another source of brush up, I would like to say. So firstly, the slump test we have. Excuse me. Yeah, so firstly, we have the slump test. So again, I need not have to explain what a slump test is, what the workability is, and all of it. So these are 5 basic tests that it is actually performed before casting any concrete for any structural unit, for that matter, whether it is a beam or a column or a slab, any of the structural unit. Before that, these tests have to be performed by the QA and QC team. So one is the slump test, definitely to check its workability, how easily concrete can be worked with respect to placing of that particular concrete. And VB test. So VB test is where there are 2 buckets and there is 1 cylinder down. So how fastly the concrete moves from one to another. There you will get to know what is the water cement ratio. Definitely again, here also you will be testing for what is the workability. This particular experiment is also called as a compaction factor test. And then coming to the compressive strength. So compressive strengths, there will be curing tubs. There will literally be all of these curing spaces of all of these cubes, which will be marked along with the dates. So whoever is already a site engineer now definitely can relate. So whoever is about to enter site engineer, who is about to enter into site engineering stream, this is something I would like to tell. So you will be casting a whole cube. Definitely in your college days, you would have casted the cubes. So over here, it is like the actual materials with the nice quality materials, all the aggregates, all the cement, as all the fine aggregates, along with proper proportion of water that has been used. Everything, it will be tested for 7, 14, and 28 days. And definitely the compressive strength of it from the compression testing machine, from the CTM machine, we will be testing, and then only that particular mix will be actually taken into the picture. What is the maximum load that this particular kind of concrete can actually take it into? So that is the compressive strength test that is performed for the concretes. And then moving forward, we have for the concrete mix design. So concrete mix design, in every site, you're already working might can relate by now. So this itself becomes one experiment. So there is a certain amount of admixtures on what basis you will be adding it. So especially if it is a residential area, it will be compared to infrastructure, it is a little small scale. So there are multiple trial and errors that will be happening, even though like we know there is a standard format, there is IS codes that you will be following for the concreting of the concrete mix design. But still, on the site, exactly, the QA/QC department will definitely be having their own design. What is the quantity of what materials, concreting materials, such as to be mixed? Every of these things, trial and error will be happening. So that's why that has also been included as one of the basic tests. And then finally, the flow test. This is completely to have a check on the segregation. It's like, now there are multiple components that is there in concrete. So all of these multiple components, we'll have to see, are they like completely getting segregated? On what rate of flow is this particular concrete getting segregated? So in this test, we will be performing a flow test. So concrete definitely undergoes through all of these various kinds of tests for its workability, for its strength, for the segregation that it is happening, a complete mixed design. All of these things has to be considered by hook or crook before the actual casting in a bigger picture or a larger scale takes place. So that is where concreting definitely plays a vital role, irrespective of any kind of project that is there. Whether it is a residential kind of project, whether it is industrial related project, or if it is a commercial space project. For any of these particular execution, before concreting stages takes place, these particular tests and those the previously mentioned process of the concrete is like a whole Bible, I can tell. So they will have to take that whole particular procedures. So next, let's completely have a look at what are the different grades of concrete that we have. So currently in Indian market, we have all of these mentioned grades over here, starting from M10 till M80. So all of these, how it has been bifurcated is, like you're seeing over here, it is into three major segments. So firstly, it is for ordinary concrete, where we have for lesser compressive strengths. So this is the characteristic strength M10, like by now you will definitely know. So 10, 15, 20, all of these particular numbers, definitely they signify the characteristic strength of the concrete. So M10 to M20, all of them with a grade, with a difference of 5 in between the numericals, are the ones that has been bifurcated. Ordinary concrete, they have three different kinds, M10, 15, and 20. So then we have the standard concrete, starting from M25 to M55. In standard concrete, I would like to tell that majority of the residential projects, majority of the domestic commercial related projects, all of them slightly, definitely not all of them, like most of them, at least 80% of this particular construction will be happening with respect to the standard concrete, starting from M25 till M35, M55. So currently in Indian market, definitely it does, the rates of the concrete does differ from one place to another. So say for example, in Hyderabad, currently it's somewhere around 3,800 is where it starts per cubic meter of concrete. So in Bangalore, it is somewhere close to 4,200. So Indian standards, it will be, it has a particular marginal rates, starting from 3,800 up to 5,000. So it is not like 5,000 is like an end. So definitely it can be above that also, based on the quality of or based on the brand of the concrete or the cement that you will be choosing forward. So that is where this standard concrete comes into the picture. And then finally, we have these high strength concretes. High strength concretes are basically used in the infrastructure projects, in every kind of infrastructure, especially in metro construction. Definitely for piling, for the foundation, it's a different grade of concrete. For the piers that will be constructed, it will be a completely different grade of concrete. Definitely all of these in detail, I will be explaining it to you in the next section about infrastructure in metro that we will be talking about. I'll be telling about which grade of concrete will be used there. So this way, the high strength concretes will be used in infrastructural projects because there is a lot of live loads. There is a lot of humongous amount of load that will be passing through these particular structures. Even in high-rise buildings, for the foundation of these high-rise buildings, just in case if it is a pile foundation that is required, all of these high-strength concretes have been used. So based on the IS codes of 456 and 1343, we have the grades of concrete that is available in India from M10 till M18. So these are the various kinds of various available concrete grades that is currently there in the market. So by now we have come to the end of the concreting part of the session. So after substructure, superstructure, then coming with bar bending schedules, we have come for the concreting part. By now, I'm sure you will have a complete idea on what are the things that has to be considered during the concreting processes, what are the mistakes that it shouldn't be made, what are the various types of concrete that is available in the market, and how the flow of the work that actually keeps going, what are the various tests that you will have to consider. All these things about concreting, by now you have a clear picture is what I believe. So in the next segment, we will be talking about the interiors of the projects that we will be handling. Okay, so thank you.